So most of this stuff you should have seen before. We're going to have some properties. Okay? Does anybody remember what the commutative property says? What does the commutative property basically allow us to do? Anybody remember? Kind of remember talking about it, just don't really remember what it is? So the commutative property basically says, if you want to do 2 plus 3, what is that actually going to be the same thing as? 3 plus 2. Those two things are the same. And then also you could do 2 times 3 is the same thing as 3 times 2. We technically have two different commutative properties. We have a commutative property of addition. We have a commutative property of multiplication. Which one do you think that is? That's a commutative property of addition. That's a commutative property of multiplication. Do we have a commutative property of subtraction? Why not? Because subtraction doesn't work both ways. 2 minus 3 is not the same thing as 3 minus 2. Does it work with division? No, it's only going to work with addition and multiplication. Yes? Simple? Commutative property means you can switch order, right? Okay. The next one is the what the associative property lets us do. Well, that one, think of it this way. If I have to add 2 plus 3 plus 4, there's actually two different ways I can add those together. If I want, I can go 2 plus 3 is 5, and then 5 plus 4 is 9. Or I could do the 3 and the 4 first, which would be 7. Either way, I would get 9. So the associative property basically says if it's all addition, or what other property or what other function will this work in? Multiplication. If I have to do 2 times 3 times 4, okay? It doesn't matter if I do 2 times 3 first, that's 6, and then 6 times 4, 24, or I could do 3 times 4 is 12, and then 12 times 2 would be 24. It doesn't matter the order in which I do it. As long as it's all addition or all multiplication, order don't matter. Make sense? Easy peasy? Okay. What's the third property? Okay. What's the distributive property say? This is the one most people actually do remember. Anybody remember, or can you give me an example of what the distributive property says? What do you think?
Kind of like divide the equation chunks.
I think you're on the right track. What do you think?
Like distribute the number, like distribute, I don't know.
So distributive property basically says if I have to multiply a number or anything by like an addition problem, okay? So I want to do 3 plus 4, but then times that whole thing by 2. What is another way that I could do that?
Do 3 times 2.
I could do 2 times 3 and 2 times 4. and then I can add those together. So I could add them first and then multiply, or I could multiply each term and then multiply, right? Either way will work. Now, a lot of people have trouble even seeing any use of the distributive property. But here's one thing that, you know, how many people have seen those little memes of how Common Core math is so bad? Like they see the weird looking house and go, oh, the first house ever built with Common Core math. Common Core math is mainly just about showing people multiple ways of doing the same problem. That's all it really is. If you guys had to do 46 times 8, wouldn't you normally stack it like that?
Yeah.
And you'd go 8 times 6 is 48, carry the 4, 32, 36. Yes? Easy? That's a great way of doing things. It really is. But here's another way. Now, would you agree that I want to do 8 and 46 is the same thing as 40 plus 6? Is that the same thing? Great. What's 8 times 4? 32, and then just add a 0 because it's 40. 6 times 8 is 48. Now add them together. Now, it works. It will work every single time. Is this a great way of doing things? I don't know. Might work for you, might work for you, may not work for you. I don't know. I think this is a better way to do it mentally. Like if I didn't have a calculator and I had to do 46 times 8, to me, I'm probably going to make mistakes doing this in my head without writing it down because I'm going to, forget to carry correctly or something like this. Where here, I can basically do that in my head. And all I have to do is think, oh, that's 320, that's 48. All I have to do is 320 plus 48 in my head. I think that to me might be an easier way to do things. Yes? Okay. Let's talk like terms. What are like terms? Give me some examples.
Like 2x
2x,
plus like 1 or 3x.
3x. What are some other like terms? So it's a 2x and 3x. Just label them.
Y.
9x, negative 7x. Like these are all like terms, right?
Yeah.
What if I gave you 2xy squared? Can you give me a like term to that?
3x y squared.
3xy squared. Negative 8xy squared, right? 42xy squared. These are all like terms, yes? What can we do with like terms?
Add them all.
Add or subtract. So if I have 5x plus 7y minus 2x plus 5y squared, okay? Do I have any like terms in here?
Yeah.
Where?
5x.
5x and 2x make
3x.
3x. Can I add those two too?
Yes.
Is that 12y? Y squared?
Yes.
Why? Why are these not like terms?
Because the 5 squared is squared.
That one's squared, that one's not. They're not exactly like terms. They have to be exact. Okay? These are the same thing. This is 5 apples, take away 2 apples. I've got 3 apples. This is, I've got 7 oranges, but over here I've got 5 mandarin oranges or grapefruit, whatever. Like they're not the same thing. They're close, but they're not exactly the same thing. So no, you cannot add those together. Does that make sense? Okay. Now, if I give you something like this, talk some terminology here. Okay? This 7 right here, in this polynomial, so that's a polynomial, it's got 3 terms, right? So in this, that 7 is what we call a coefficient. That 5 would also be considered a coefficient. But that 8 is actually what we call a constant. Now, why are these two numbers coefficients and that's a constant? What's different about that 8? Doesn't have an x attached to it, right? So, and here's basically why we consider that a constant. If I give you 7x squared, was it plus 5x minus a, something like this, and I say let's set that equal to y, and let's start plotting some points, right? You plug in a 0. 0 squared is 0, 0 times 7 is 0, 5 times 0 is 0, minus 8, you get negative 8, right? You plug in a 1. 1 squared is 1. 1 times 7 is 7. 5 times 1 is 5. Minus 8, you go 5 plus 7 is 12. 12 minus 8 is 4. You plug in a 2. 2 squared is 4. 4 times 8, or 4 times 7 is 28. 2 times 5 is 10. What is staying consistent here? What's not changing?
The 8.
The 8. Minus 8, minus 8, minus 8. You're always going to minus 8. That's why we consider that a constant. That part is not going to change. But these first two, depending on what we plug in for x, isn't that going to change? Bless you. So that's why we consider that a constant where those are coefficients. Now, in this, how many terms, though, does this have?
0.
There are 3 terms here. Terms are basically just going to be separated by pluses and minuses. That's all that is. We will continue talking about this tomorrow, but make sense?
Yeah.
All right.